RHS Pre-Calculus presents Tom and Jerry chasing linear and angular velocity. One day.
Spike was sleeping outside his doghouse when he awoke to a loud ruckus. He picked up his head to see his old pals Tom and Jerry circling around him.
As they circled around him,
Spike realized that Tom and Jerry were always 5 feet from him. Noticing that the situation made him the center of the circular path around which Tom and Jerry were running, Spike began thinking about his days back in high school math class when they learned about linear and angular velocity and how these velocities relate to revolutions.
as he thought,
Spike was able to recollect the basic information surrounding these topics.
first,
He remembered that while linear velocity is how fast a point moves along a circular arc, angular velocity is how fast the central angle of a circle changes.
thinking even harder,
Spike was able to remember that linear velocity, represented by the variable v, is equal to the arc length divided by time, or s divided by t.
then,
Spike remembered that angular velocity, represented by the variable w, is equal to the same expression except the arc length, s, is substituted for the central angle, theta.
still pondering,
Spike recalled that the number of revolutions made in a given amount of time is generally associated with the linear and angular velocity calculations.
furthermore,
Spike was able to remember that revolutions per minute is neither linear nor angular velocity. It is simply a unit.
yay!
After noticing that Jerry was making exactly 8 revolutions every minute, Spike decided that he wanted to find Jerry's
Linear,
velocity in miles per hour.
to do so,
Spike wrote the information he knew in a patch of dirt with his nose.
then,
Spike proceeded to multiply his original fraction by...
one in disguise. First,
Spike multiplied 8 revolutions per minute by 2 pi r feet over 1 revolution.
or the circumference of the circular track on which Jerry was running.
Spike knew that
In this case,
2 pi r was equal to 10 pi because the radius
or the distance Jerry maintained from Spike.
was 5 feet.
In addition,
Multiplying by the circumference over 1 revolution allowed Spike to accurately substitute revolutions for feet. However, Spike knew that he did not want the distance portion of his unit in feet.
he wanted it in miles. Thus,
Spike continued by multiplying 1 mile over
it's equal.
5,280 feet.
Continuing,
Spike multiplied by 60 minutes over 1 hour. This computation yielded Jerry's
linear,
velocity
or speed,
of 0.90 representing pi miles per hour, which is equal to
approximately.
2.8560 miles per hour.
Turning his attention to Tom,
Spike noticed that Tom was only making 7.5 revolutions per minute.
with this in mind,
Spike set out to calculate Tom's
angular,
velocity in radians per second.
after writing down the information that he knew,
Spike applied his knowledge that 2 pi radians is equal to 1 revolution in order to convert revolutions to radians.
to convert minutes to seconds,
Spike applied his knowledge of the fact that there are 60 seconds in 1 minute. This computation yielded Tom's
angular,
velocity of 0.25 pi
or 0.7854.
radians per second. Realizing that he cannot effectively compare Tom and Jerry's movement, Spike decided to convert Tom's angular velocity to linear velocity. This process simply entailed changing the seconds to minutes and then to hours.
And,
Changing radians to miles.
but wait, to go from radians to miles, Spike had to go through revolutions.
This computation yielded Tom's
Linear,
velocity of 0.8523 pi
or 2.6775.
miles per hour.
Phew!
That was hard.
If only there was a shortcut.